Hello, ladies and gentlemen. Today I'm making a video to go over all of the questions on the study guide. Pay close attention. And if you have any questions, obviously I am always here. So, first we have two-dimensional analysis questions. I'm going to go to the in person sheet that I am definitely going to give you for the test. This is that sheet. If you're remote, this will be attached to your test. So, how many kilometers are there in 65.21 decimeters? First of all, in order to get complete credit, you must list the known and the unknown, and then show all your work, including your units. So, first, our known is 65.21 decimeters. Our unknown, how many kilometers? Okay. Take my known and put it over 1. That is how all of these start. Do not forget your units here. Next, I need to go from decimeters to whatever this says, decimeters to meters. So 10 decimeters equals 1 meter. I need my decimeters to cancel out, so my 10 decimeters is going to go on the bottom, and on top I'm going to write equals 1 meter. Next, we need to go to kilometers. So you'll notice that 1 kilometer equals 1,000 meters. So on bottom, I have 1,000 meters. On top, I have 1 kilometer. Then I'm going to go ahead and do all of that math. Generally, if it's on top, you're going to multiply. If it's on bottom, you're going to divide. So when we do this, we are going to get 0.006521. And our units are going to be kilometers. Go ahead and box in our answer. For number 2, I have how many seconds are there in 1.33 years? Again, we write our known and our unknown. Our known is whatever number is given to us, 1.33 years. My unknown says how many seconds. So we're going to start with our known over 1. And we're going to move it to seconds. So from years, we can go from years to days. So 1 year equals 365 days. From days to hours, 1 day is 24 hours. Hours to minutes, 1 hour, 60 minutes. And finally, 1 minute, 60 seconds. I'm going to go ahead and multiply all of that out. And when I do, my answer is going to be 41,942,880 seconds. And that gets squared. Next, we're moving on to one-step mole problems. When we do that, we're going to use the top part of our mole, the top part of our mole diagram up here. Make sure you know all of these. It will be on your test. You will have to fill in each of these blanks. So let's go ahead and do that. For mass, when we go from moles to mass, we have molar mass on top. On the bottom, we have 1 mole. If we go from mass to moles, On the top, we have 1 mole. On the bottom, we have the molar mass. Particles to and from the mole. If we go from the mole to particles, we have 6.02 times 10 to the 23rd. And on the bottom, we have 1 mole. If we do the opposite, if we go from particles to mole, on the top, we have 1 mole. And on the bottom, we have 6.02 times 10 to the 23rd. Remember, particles can be anything in atoms, molecules, or formula units, depending on if we're talking about an element, a molecule, or a compound. Next, we have volume. And if we go from moles to volume, on top we have 22.4 liters, and on bottom we have 1 mole. If we go the opposite way, from volume to moles, you have 1 mole on top and 22.4 liters on the bottom. Using this, we can go from any one unit to any other unit. It's like our roadmap. So, our first one, we have how many atoms are in 0.250 moles of silver. Same rules apply, so we need to write our known and our unknown. Our known is 0.250 moles of silver. Our unknown, how many atoms. So if we go back to our picture, we're going to go from the mole to the number of atoms. So we're going to use this one, multiplying by 6.02 times 10 to the 23rd over 1 mole. Take our known and put it over 1. Do not forget our units. And then we're going to multiply that out and get our answer. When we multiply that out, we're going to end up with 1.51 atom times 10 to the 23rd atoms of silver. Go ahead and pause it if you need to write any of those 3 down. And I'm going to clear all of that writing. And we're going to move on to number 4. For number 4, it says how many moles are in 3.25 times 10 to the 25th formula units of NaOH, sodium hydroxide. So my known, 3.25 times 10 to the 25th formula units of NaOH. We can abbreviate formula units by using the F and the U, but we still have our chemical formula of NaOH. Our unknown, we're going to moles. Okay. I'm going to start with my known and put it over 1. Then I'm going to check my chart. Using my chart, I know I'm going from formula units to moles. Formula units are down here in the particles, and we're going to moles. So that's the center. So I'm going to use this conversion factor. 1 mole over 6.02 times 10 to the 23rd. So on top, I have 1 mole of NaOH. On the bottom, I have 6.02 times 10 to the 23rd formula units of NaOH. My units are going to cancel, and I'm going to end up with moles of NaOH. When I do the actual division, I'm going to end up with 53.99 moles. For number 5, it says how many grams are in 3.50 moles of lithium. So for my known, I have 3.50 moles of lithium. My unknown, how many grams of lithium? Take my known and put it over 1. I'm going from moles to grams. From moles in the center to grams. So I need my molar mass from moles in the center to grams. So I need my molar mass over 1 mole. When I go down here to my periodic table, and you guys can all look up lithium's atomic mass is 6.94. So I have my atomic mass 6.94 grams of lithium over 1 mole of lithium. Then I'm going to go ahead and multiply that. And end up with 24.29. And for my units, the moles would cancel out, so I would have grams of lithium. In our next example, our last one-step example, we have how many moles are in 57.34 liters of